Only a few months after Einstein published general relativity, a man named Karl Schwarzschild published a solution to Einstein's equations. Now known as the Schwarzschild metric, it describes some very curious and bizarre objects. In fact, they were so bizarre that Einstein himself dismissed them as objects that could not exist in reality. But for once, Einstein was wrong. These objects have been indirectly observed before. I'm talking about black holes. Black holes are small, but massive objects that have a gravitational pull so great that, beyond a certain point, nothing can escape. Yes, nothing. Even light is gravitationally lensed into the black hole, and it never escapes again. Relativity predicts that there are boundaries in spacetime, called horizons. Horizons are one-way paths, and every black hole has an event horizon. Beyond the event horizon, you'd need to be moving faster than the speed of light to escape. And relativity already established the impossibility of that happening. If you were to look at a black hole, you would see a large disk of matter, known as an accretion disk, slowly circling into the center. And if you managed to look into the center, you would see nothing. Absolutely nothing. It would be a black sphere, because no light can reach us from inside that sphere. We now believe that there's one such supermassive black hole, one enormous black sphere, at the center of every galaxy. Each of those monstrous black holes is as big as a few million of our suns put together, and the entire galaxy orbits around this one sphere. But wait, it only gets stranger once you pass that event horizon. Anything that falls in is ripped apart into the smallest subatomic particles through a process called spaghettification. This is how it works. For anything inside a black hole, the gravitational pull at the bottom is far stronger than the pull at the top. The result is that the object is stretched from head to toe until it is no more than a string of tiny particles. Then, this string reaches the center of the black hole. At the center is a singularity. It's a point of infinite density, a single point. It's a point that, despite its size, has as much mass as hundreds of thousands of suns. At the singularity, all the laws of physics break down. Gravity becomes infinite. Time stops, and no one can understand what's going on. Relativity, the theory of the very heavy, cannot deal with the minute sizes. Quantum mechanics, the theory of the very small, cannot deal with the huge masses. But for now, let's go back to the outside of the black hole and consider the question, how do these monsters even form? A black hole forms when a massive star runs out of fuel and collapses onto itself. Usually the star is a neutron star, which is also an immensely dense object. Neutron stars are usually about 12 kilometers wide, but weigh as much as 2 suns. Now once these collapse, they turn into black holes, sucking in everything that dares to approach it. If another black hole were to get too close, the two black holes begin circling each other, always moving closer to each other until, eventually, they merge, sending gravitational shockwaves rippling outwards at the speed of light. This process is aptly called the dance of death. One day, there may be enough dances of death to create supermassive black holes. By then it's possible that the universe will be made of nothing but black holes. But that day is a long way off. So you can live your life knowing that you probably won't die by getting swallowed by the universe's most mysterious and deadly objects.